Hey everyone, welcome back to the College Algebra playlist. In previous videos, we took a look at rational expressions, and we showed how to multiply and divide them, as well as add and subtract them. And we also looked at complex rational expressions, which are essentially fractions within fractions. In this video, I want to take everything we've learned about rational expressions and apply it to some examples. Alright, so let's get started. Okay, here we go. Example 37. Here we're asked to simplify x squared minus 16 over x squared minus 5x plus 4. In this rational expression, both the numerator and the denominator are factorable. Okay, so let's factor both pieces to see if anything cancels. Up top, we have x squared minus 16, which is the difference of squares. Okay, so we know how to factor that, right? We get x plus 4 times x minus 4. All right? And in the bottom, this trinomial can be factored via trial and error, right? So let's think of two numbers that multiply together to give 4 and add together to give negative 5. The answer is negative 4 and negative 1. Okay? So this bottom piece factors like this, okay? And we can see that the x minus 4 and the x minus 4 are going to cancel. So let's get rid of those. And it leaves us with x plus 4 over x minus 1. So this is our final answer. All right. Moving on to example 38. Here we're asked to multiply and simplify this business. All right, so we have two rational expressions being multiplied, and they have trinomials that are factorable. Okay, they're made up of factorable trinomials. So when we multiply this, we need to put everything in its factored form to see if anything cancels. Okay, so let's start with the top left piece, y squared plus 2y minus 24. All right, that can be factored as y plus 6 times y minus 4. All right, then let's move to the bottom left trinomial. That can be factored as y plus 6 times y plus 6. So that's actually a perfect square trinomial. Okay. Moving to the top right piece, y squared minus 10y plus 24 can be factored as y minus 6 times y minus 4. Okay? And lastly, this bottom right piece can be factored as y minus 4 times y minus 4. So this is also a perfect square trinomial. Okay? Let's take this to the top of the screen because we've run out of room. All right, here's what we have. All right, when we multiply these fractions together, right, we get one big fraction. And now we can start to cancel some things, right? The y plus 6 cancels with the y plus 6, and the y minus 4s go away, as well as the y minus 4s over here. Okay, so that leaves us with y minus 6 over y plus 6. All right, that's our final answer. Okay. Moving on to example 39. Here we go. Here we're asked to divide and simplify. All right? So here we want to do the same thing, right? We want to factor each piece to see if anything cancels. All right? So up top, x squared minus 9, that is the difference of squares. Okay, so it factors as x plus 3 times x minus 3. All right? X squared plus 6x plus 9 can be factored as x plus 3 times x plus 3. Right? That's a perfect square trinomial. All right? And x squared minus 2x minus 3, that can be factored as x plus 1 times x minus 3. All right? And then this bottom right piece, right, that can be factored as x plus 3 times x minus 1. All right? Let's take this to the top of the screen. Okay? We're dividing this by this, right? So that's the same thing as multiplying by the reciprocal of this expression here. Okay? So we swap the numerator and the denominator there to turn this into a multiplication problem. All right? We can combine these into one fraction, right? One big fraction, and we see that some stuff cancels. All right? A lot of stuff cancels, actually, right? The x plus 3's go away, and the x minus 3's go away in blue, and the x plus 3's in green go away as well. So that just leaves us with x minus 1 over x plus 1. So that's our final answer. All right? Moving on to the next example, example 40. Here we're asked to add and simplify. All right? So this is getting a little harder now, right? It's much harder to add and subtract fractions than it is to multiply and divide. All right? Because with this, right, with something like this, we have to get a common denominator. All right? And whenever it involves variables, right, we take the common denominator to be the product of these two things, right? That's the LCD. Okay? So we need to get a plus 1 times a minus 3 in both denominators here. Okay? So to do that, we're going to multiply the first fraction by a minus 3 over a minus 3. All right? And we'll multiply the second fraction by a plus 1 over a plus 1. All right? Here's the result of the multiplication, right, in both cases. Okay? So we have 4 times a minus 3 over this common denominator, and we have 5 times a plus 1 over the common denominator. All right? So now we're ready to condense two fractions into one, right? When we add this, we get 4 times a minus 3 plus 5 times a plus 1 up top. Okay? When we distribute, right, we get 4a minus 12, and then 5a plus 5. Okay? We can see that we have some like terms going on here, right? We have 4a and 5a in blue. Those add up to give 9a in blue. And then in red, right, we have these constants floating around. Negative 12 plus 5 gives us negative 7. Okay? So this is my final answer. We can't simplify this any further. All right? Moving on to example 41. Okay, here we go. Here we're subtracting 4b over b plus 1 minus b plus 1 over 4b. Okay? So once again, we're going to take the common denominator to be the product of these two denominators. Okay? So 4b times b plus 1 needs to show up in both denominators before we can subtract this. Okay? So let's multiply each fraction by something equal to 1 to get the common denominator. All right? We're going to multiply 4b over b plus 1 by 4b over 4b. Okay? And then we'll multiply this second fraction by b plus 1 over b plus 1. Okay? That'll give us what we want. So when we multiply these fractions, right, we get 4b times 4b over the common denominator. All right? And then up here we get b plus 1 times b plus 1 over the common denominator. Okay? So, remember my advice. Whenever we subtract rational expressions like this, we need to include brackets around this piece here. All right? Because we're subtracting this entire numerator. All right? We're subtracting b plus 1 times b plus 1. Okay? So to avoid sign errors, be sure to include brackets here. All right? 4b times 4b is 16b squared. All right? And then in the brackets, right, we can FOIL b plus 1 times b plus 1 to get b squared plus 2b plus 1. Okay? So next, to get rid of those brackets, we're going to distribute this minus sign to each piece, right? Minus b squared minus 2b minus 1. Okay? So next, we can see that 16b squared and negative b squared are like terms. Okay, so we can add those together. And we'll get 15b squared in blue here. All right. So we have 15b squared minus 2b minus 1. And that, I believe, can actually be factored. This is a trinomial that can be factored, okay? As 5b plus 1 times 3b minus 1. All right, so we factored there to see if anything would cancel, right? And in this case, it turns out nothing cancels. All right, so because of that, these answers are both correct, all right? You can report either one and you'd be correct. All right. So moving on to example 42. Here we're asked to simplify a complex rational expression. All right, we have fractions within fractions. Okay. So remember what the first step tells us to do for problems like this. All right, think back to that 4-step recipe I showed you in the previous video. All right, the first thing we want to do is get a single rational expression in the numerator. Okay, and we already have a single expression in the denominator, so we'll just leave that alone for now. All right, let's add 2 over a and 7 over b. All right, the LCD is going to be ab. Okay, so I need ab to show up in both denominators. So to get what I want, I multiply both fractions by something equal to 1 in blue here. All right. So up top, we get 2b over ab plus 7a over ab. Okay? So we're ready to add these fractions. And we get 2b plus 7a over ab. All right? So next, we're going to write this down as a division problem, right? We're dividing this by this, okay? I rewrote b as b over 1, all right, to make it clear what we're doing, okay? So when we divide these, what we can do is multiply by the reciprocal of this fraction here, right? So we get 2b plus 7a over ab times 1 over b, all right? When we multiply those fractions together, we get 2b plus 7a over ab squared. All right, so that's our final answer. All right, example 43 is pretty hard. All right, so fasten your seatbelts. This is going to get a little messy. All right, but we can handle it, no problem. All right, here we have 3 over x plus 1 plus 2 over x minus 1. Okay, and that whole thing is being divided by x minus 1 over x plus 1. All right, so we already have a single rational expression in the denominator. All right, but up top we have some addition, right? So we need to make this fraction addition happen, all right, to get one fraction. All right, so the LCD is x plus 1 times x minus 1. All right, so we multiply this first fraction in black by this fraction in blue, right? That's something equal to 1. And we multiply the second black fraction by this second fraction in blue here. All right. So when we multiply, right, we get 3 times x minus 1 over the common denominator plus 2 times x plus 1 over the common denominator. All right. So here we're ready to combine these two fractions into 1. All right. And this is what we get. Okay, let's take this to the top of the screen. All right. When we distribute up here, right, we have 3x minus 3 plus 2x plus 2. Okay. And at this stage, if we want to, we can add like terms and add constants. Okay, we don't have to do this yet, but I'm going to go ahead and do it right now to clean this up nicely. Okay, so 3x plus 2x in blue, right, that gives us 5x. And then negative 3 plus 2 in red, that gives us minus 1. Okay? So this is a little cleaner now, and we can write it as a division problem. Okay? So we have this divided by this. Okay? Let's rewrite this as a multiplication problem, right? Let's multiply by the reciprocal. Okay? And then let's see what we get. All right, this is the result of the fraction multiplication. Does anything cancel? Yes, it does. The x plus 1 cancels with the x plus 1. Okay? And that leaves us with 5x minus 1 up top over x minus 1 times x minus 1, which is x minus 1 squared. Okay? So this is our final answer. Alright, that does it for this video. Thank you for watching, and like and subscribe.